Solving 3x3 system of equations. So your steps for solving a 3x3 system of equations are you're going to solve for a variable, you're going to substitute your expression that you get in two other equations, you're going to solve the remaining 2x2, and you're going to substitute the two solved variables that you get for the third. So the first problem we're going to do here, you have your three equations, 4x plus 4y plus z equals 25, negative x plus 4y plus z equals 5, negative 4x plus y equals negative 14. So we're going to solve for a variable, and the easiest one to solve for out of these is negative 4x plus y equals negative 14. So we're going to want to solve for y. That's the easiest one to solve for. So you're going to take your equation, add 4x to both sides. The 4x and the 4x, negative 4x cancel out. And so then you get y equals 4x minus 14. So now you're going to substitute this into the other equations, and you'll substitute this, what you got in, for y. So in this equation, the very top equation, 4x plus 4, this would have been y, except we're substituting it in now for with 4x minus 14. So plus 4 times 4x minus 14. Oops. So now we'll substitute the expression into the other equations, and what we'll do here is you'll take the top equation, or whichever one out of the two that you didn't use for this, for solving for y. So now we'll substitute the expression in for the other equations. So we're substituting in for y here, so we'll use the top equation, 4x plus 4 times x minus 14, and substituting in, this would have been y, plus z equals 25. And then you distribute the 4 across, so you get 4x plus 16x minus 56 plus z equals 25. So now after you've distributed the 4 across, then you're going to want to simplify or combine your like terms. So the 16x and 4x become 20x plus z minus 56 equals 25. You're going to add 56 to both sides so that you can isolate your 2x2, and you get 20x plus z equals 81. Again, we're going to solve for another equation, substituting in our expression. So we'll use negative x plus 4y plus z equals 5. And instead of using y, we'll substitute in 4x minus 14, because that's what we got up here. So then once you distribute the 4 across to everything inside the parentheses, you get negative x plus 16x minus 56 plus z equals 5. Then you'll add 56 to both sides because you're trying to isolate for your 2x2. You get 15x plus z equals 61. So now you're going to solve your 2x2. Your 2x2 consists of these two equations here. 20x plus z equals 81 and 15x plus z equals 61. And to solve these, we'll make the top one negative to cancel out the z's, and then we'll add them together so that we get, well, the negative 20x plus 15x would get negative 5x. The z's cancel out, and negative 81 plus 61 is negative 20. And so we're going to solve for x, so we're going to divide by negative 5 on both sides, and we get negative x equals negative 4 divided by the negative 1, and you get x equals 4. And so then now that we have x equals 4, we're going to plug in x back into one of these equations here. It doesn't really matter which one. This one's just going to be easier. So we'll do 15 times 4, because we're replacing x with 4, plus z equals 61. 15 times 4 is 60, plus z equals 61. Then we'll subtract 60 from both sides, and we'll get that z equals 1. So now what we're going to do is we're going to substitute the two solved variables for the third. We have these two solved variables, and we're just going to plug them into any equation up here. We're just going to use the negative 4x plus y equals negative 14. So substitute the x for 4. So Negative 4 times 4 plus y equals negative 14. So you get negative 16 plus y equals negative 14. So after you distribute, you get negative 16 plus y equals negative 14. And then you get y equals 2 when you add 16 to both sides because you're solving for y. And then you're going to turn this into your answer by having it alphabetically ordered by x, y, and z, and then you're going to correspond that with x is 4, y is 2, and z is 1. So the next problem we're going to do, negative 5x plus 5y minus 5z equals 0, and x minus y minus z equals negative 6, and negative 2x minus 3y plus z equals negative 1. And so the same steps as before, we're going to solve for a variable, and we'll solve for x on this one. So all you have to do is add y and z to both sides, and you'll get x equals y plus z minus 6. And we'll substitute the expression into other equations. So we'll use the very top equation again. So then we're going to substitute in, we're going to replace x with y plus z minus 6. So negative 5, what would have been x now is y plus z minus 6 plus 5y minus 5z equals 0. Then we distribute the negative 5 into everything inside the parentheses, and you get negative 5y minus 5z plus 30 plus 5y minus 5z equals 0. And now what happens here is when you combine your like terms, because that would be the next step, the negative 5z and the negative 5y and the positive 5y will cancel out. And this allows you to skip the third step because you no longer have a 2 by 2, you're just solving for one variable. So then the y's cancel out, and then the negative 5z and negative 5z combined to become negative 10z. So you'd have negative 10z plus 30, but then you're solving for a variable now, so you want to subtract 30 from both sides, and you'll get negative 10z equals negative 30. And divide by negative 10, and you'd get z equals 3. So now you have your z value, and you also have something to substitute in for x. And again, this is allowing you to skip this third step here, and it makes the problem just a little bit shorter. So now with this bottom equation, we'll substitute the x with y plus 3 minus 6. So negative 2 times y plus 3 minus 6 minus 3y plus 3 equals negative 1. And then negative 2y, well, of course, you're going to distribute the negative 2 across. So then you'll get negative 2y minus 6 plus 12 minus 3y plus 3 equals negative 1. And then you'll combine like terms. So the negative 2y and the negative 3y combine to be negative 5y. The negative 6, the 12, and the 3 all combine to become 9. And the negative 1 is just outside the equation, so that stays the same. So the negative 5y plus 9, you want to solve for y, so you're going to subtract 9 from both sides so you can isolate your variable, and you'll get negative 5y equals negative 10 because you subtracted 9, and you're going to divide by 5, or negative 5, on both sides. And when you divide negative 10 by negative 5, you get y equals 2. So now you have a z and a y. So you can skip that third step and go to the fourth one and substitute the two solved variables for a third. So you have z equals 3 and y equals 2. So what we're going to do is substitute the z and the y in with 3 and 2 and this middle equation here. So x minus 2 minus 3 equals negative 6. And so we'll do x minus 2 minus 3 equals negative 6. And then x minus 5, because when you combine these you get negative 5, equals negative 6. And then you're going to add 5 to both sides because you're solving for your x. This is your third variable, last variable, and x equals negative 1 when you add 5 to both sides. So now again, you're going to order them alphabetically, and you should get negative 1 for x, 2 for y, and 3 for z.